Manufacturing is one of the oldest industries in the world, and it is being fundamentally restructured by AI right now. We're not talking about science fiction robots in the distant future. We're talking about changes that are happening on factory floors today, in quality control, maintenance, supply chain, production planning, and design. And the companies that move early on this are building competitive advantages that will be nearly impossible to close. Welcome to Node Pulse. Today we're talking about how artificial intelligence is reshaping manufacturing. This is relevant whether you work in manufacturing, invest in it, run a business that touches it, or just want to understand where one of the world's most important industries is heading. The transformation is real, and it's moving fast. Let's break it down. Let's start with predictive maintenance, because it's one of the highest ROI applications of AI in manufacturing, and it's relatively mature. Traditional maintenance is either reactive, you fix things when they break, or scheduled, you service equipment on a calendar, whether it needs it or not. Both approaches are inefficient. Reactive maintenance causes unexpected downtime, which is extremely expensive. Scheduled maintenance wastes resources servicing equipment that doesn't need it. Predictive maintenance using AI analyzes data from sensors embedded in machinery, vibration, temperature, pressure, sound, electrical current, and uses machine learning to detect patterns that precede equipment failure. The system learns what normal looks like for each machine and flags anomalies before they become failures. Companies using AI-driven predictive maintenance report reductions in unplanned downtime of 30 to 50% and maintenance cost reductions of 20 to 25%. For a large manufacturing operation, those are enormous numbers. Platforms like IBM Maximo, PTC ThingWorx, and Siemens MindSphere are leading in this space. Quality control is another massive application. Traditional quality control involves humans visually inspecting products or using statistical sampling to catch defects. Both approaches miss things. AI-powered machine vision systems can inspect 100% of production output at line speed with greater accuracy than human inspectors. Computer vision models are trained on thousands of images of defective and non-defective products, and they identify defects, surface scratches, dimensional variations, color inconsistencies, assembly errors in real time. The system can stop the line or flag individual units automatically. Companies in automotive, electronics, food and beverage, and pharmaceuticals are deploying these systems widely. The defect detection accuracy rates are often in the 99+% range for well-trained models. Supply chain optimization is where AI is having its most complex and far-reaching impact. Supply chains involve thousands of variables: supplier lead times, transportation routes, inventory levels, demand forecasts, geopolitical risks, weather disruptions. Traditional planning tools struggle with this complexity. AI models can process enormous amounts of data and produce demand forecasts that are significantly more accurate than statistical models, optimize inventory positioning across distribution networks, and identify supply chain risks before they materialize. The disruptions of 2020 and 2021 exposed how fragile many supply chains were, and AI-driven supply chain risk tools are now a priority investment for manufacturers of all sizes. Production planning and scheduling is an area where AI-generated optimization can eliminate a lot of the inefficiency that exists in manufacturing. The classic challenge is the scheduling problem. Given a set of jobs, machines, labor constraints, and delivery deadlines, what's the optimal sequence and allocation? This is computationally complex and traditionally done by experienced planners using a combination of software and intuition. AI tools can solve these scheduling optimization problems at a level that humans can't match manually, often finding solutions that reduce changeover time, improve machine utilization, and meet more delivery commitments simultaneously. Generative design is a newer application that's exciting because it works at the product design stage rather than on the factory floor. Engineers input design constraints, the load requirements, material, weight limits, manufacturing process, and AI generative design software produces optimized geometries that meet those requirements. The results are often organic-looking structures that a human designer would never conceive of, but which are structurally superior and use less material. Autodesk's generative design tools have been used to redesign airplane parts, automotive components, and industrial equipment to achieve significant weight reductions without compromising strength. Less material means lower cost, and in transportation applications, significant energy savings over the life of the product. Process optimization across production lines is another area where AI, particularly reinforcement learning approaches, is showing results. Reinforcement learning algorithms can be trained to tune process parameters, temperatures, pressures, chemical concentrations, timing, to maximize yield and quality while minimizing energy consumption and waste. Google's DeepMind famously applied reinforcement learning to optimize cooling systems in their data centers, reducing cooling energy use by 40%. Similar approaches are being applied in chemical manufacturing, semiconductor fabrication, and food processing. Collaborative robots, known as cobots, are becoming more capable thanks to AI. Traditional industrial robots are programmed to perform fixed repetitive tasks and operate in caged areas away from humans due to safety concerns. AI-powered cobots can perceive their environment, adapt to variation, and work safely alongside human workers. They can pick irregular items, assemble variable configurations, and hand off tasks fluidly with human teammates. The falling cost of cobots and the improving ease of programming them, some can now be trained by demonstration rather than code, is accelerating their deployment in small and mid-sized manufacturers. Energy management is a growing application as manufacturers face both rising energy costs and sustainability mandates. AI systems can optimize energy consumption across a facility in real time, managing HVAC, compressors, furnaces, lighting, and equipment startup sequencing to reduce peak demand charges and overall consumption. Some facilities are seeing energy cost reductions of 10 to 20% through AI-driven energy management, which at industrial scale is a meaningful bottom-line impact. Worker safety is an area where AI is being deployed through computer vision monitoring of factory floors. Systems can detect when workers are in hazardous zones, identify PPE compliance in real time, recognize unsafe behaviors like improper lifting technique, and alert supervisors immediately. For manufacturers with serious injury risks, these systems can reduce incident rates and the substantial costs, human and financial, associated with workplace injuries. The overall direction is clear. AI is making manufacturing more precise, more efficient, more predictive, and more adaptable. The factories that will lead the next generation of manufacturing are not just automated. They're intelligent. They learn, adapt, and self-optimize in ways that fixed automation never could. For workers in manufacturing, the shift means that the jobs that are growing are those requiring judgment, problem-solving, and oversight of AI systems, skills that remain irreplaceably human. The small and mid-sized manufacturer picture one thing worth addressing. Much of the coverage of AI in manufacturing focuses on large enterprises with significant technology budgets. But AI is increasingly accessible to smaller manufacturers too. Cloud-based quality inspection systems, subscription-based predictive maintenance platforms, and AI-powered supply chain tools are available at price points that don't require a capital expenditure most large projects would require. Companies like SiteMachine, Tulip, and Augury offer AI tools designed for mid-market manufacturers. For a 50-person precision parts manufacturer, AI-assisted quality inspection that catches defects at a higher rate than visual inspection is a real competitive advantage, not just something their Fortune 500 competitors have. The accessibility of these tools is increasing rapidly. The timeline and urgency. The companies that are moving on AI in manufacturing now are building competitive advantages that are difficult for laggards to close. It's not that traditional manufacturers will immediately fail. It's that the performance gap between AI-enabled and non-AI-enabled operations compounds over time. A manufacturer that reduces unplanned downtime by 40% through predictive maintenance has a cost structure that non-AI competitors can't match on a level playing field. That advantage shows up in every bid, every customer conversation, every hiring decision. It's not theoretical, it's operational reality. The window to be an early mover in your segment is still open, but it's narrowing every quarter. Subscribe to Node Pulse for weekly breakdowns of how AI is reshaping industries. See you in the next one.